Hi, my name is Brett Harrison, and our learning intentions for today is to recognise symmetry in nature. Hopefully, while we are talking about symmetry in nature, I can inspire Years 3-4 students to find mathematical wonders in their own environment. So, where do we start? Well, first step is to ask, what is symmetry? In essence, symmetry could be identified as an object, animal, tree, picture, or anything, so long as it can be divided, rotated, and reflected on itself or around its own axis. Its ability to rotate, flip, and mirror an image or shape and still maintain its originality. Today, we will be focusing on two distinct types of symmetry that are commonly found throughout nature. Firstly, line or mirror symmetry, mathematically known as bilateral symmetry. Bi meaning two, straight away gives us an indication that we are dealing with two equal halves. Bilateral symmetry is where you can draw an imaginary line down the vertical or horizontal axis or the center of an object, and when you fold together, they're equal. This can also be known as reflective symmetry. The second type is rotational symmetry. This is used for geometric shapes that have multiple lines of symmetry, such as an equilateral triangle. A perfect example of this is a starfish, which is classified as a fivefold degree radial symmetry. The starfish makes 5 72-degree angled turns. With each turn, the starfish looks like it was at the start. Many flowers and animals have radial symmetry. Now, we all learn best through investigation and interaction. So let's crack into the fun stuff. Here is an easy activity to start with, the bilateral symmetrical butterfly painting. This is designed to show the mirror effect of an object or an animal. First, let's grab some paper and paint. Fold the paper in half. This will create a datum or a center line and become our axis line. On one side, paint half of your butterfly. Now fold it again, give it a squish, and voila! Bilateral symmetry. So now you have a basic understanding and a reference point to this type of symmetry. And a nifty Mother's Day card. In our second activity, we're going to create a snowflake that is rotationally symmetric. Again, let's go step by step. Grab another piece of paper, kindergarten squares are ideal, and fold it in half. Then half again, then tip to tip to make a triangle. Now with scissors, cut out random sections. As we unravel the paper, we start to see similarities within the arms of the snowflake. And even notice that in its formation of the snowflake, it is also bilaterally symmetric. With our snowflake laid out, we can mark the locations of each corner, then mark one arm of the snowflake to help us see how the snowflake is rotationally symmetric. As we slowly rotate the snowflake a full 360 degrees, what do you notice? Yes, you can see that the snowflake looks the same in 4 different positions. From here, we can expand on rotational symmetry by looking at the order of rotational symmetry. This is simply done by counting how many times a snowflake can rotate so it looks the same as it did at the start point. Clearly, it has 4 90-degree or 4 quarter turns of rotational symmetry. This represents 4-fold rotational symmetry. In the same way, our starfish is a representation of a 5-fold rotational symmetry. So, my final mind-blowing activity is the geoboard spiderweb. As you can see, I've used my understanding of bilateral symmetry and rotational symmetry to create some intricate designs. What symmetrical designs can your class create? Let's cement our newly formed understandings. We can define symmetry as the ability to rotate, flip, and mirror an image or a shape along the lines of an axis and still maintain its originality. We can identify bilateral symmetry in our environment on people's faces or the wings of a butterfly. It is 2 equal reflective halves divided by the line of an axis. Then there is rotational symmetry, shapes with multiple lines of symmetry. Snowflakes and starfish are 2 good examples of rotational symmetry in nature. These are a few examples of symmetry in nature. and how it can be demonstrated in the classroom. By connecting everyday naturally occurring objects in mathematics, we can help engage our mathematical thinking, even when we're out of the classroom. Next time your class is out and about, perhaps you'll look differently at a flower or snowflake or a spider web with your new love for mathematics. I hope you've enjoyed my presentation and find it useful.